lab on friction for this Choose Your Own Adventure. I decided to observe and analyze the friction of a moving object on the floor. And so some of the principles used were Newton's second law and the momentum principle. And I also used Tracker, GlowScript, and Excel for my programs. So a little bit more on principles. I noted that the sum of the forces in the x direction would just be friction, and the sum of the forces in the y would be the normal force minus the gravitational force. And some important equations for position and velocity update are the position update and velocity update formulas, as you can see right there, and then the friction formula, which is F equals mu times delta x. So in Tracker, I inputted the video of me sliding the object on the floor. I chose the time so that there was no more force on the hand, just an initial velocity, which I calculated to be about 1.44 meters per second using the first couple of points from the plot. I found that the height of the Lysol can was about 0.025 meters, and I used this to calibrate my data. So I will show you what it looks like when I did my Tracker data. As you can see, the initial position was 0, and the mass, which I calculated earlier, was 0.538 kilograms, and this is the graph that Tracker produced. So in GlowScript, there were a couple things I changed to the Lab 5 Choose Your Own Adventure. So the initial ball position was 0, the ball mass was 0.53, and the initial velocity was 0.144. Also, the delta t was 0.017, which I found from Tracker, and the total time it ran was 0.65, which I also found in Tracker. Right here is the F net in the x direction, which I set to be friction. I found this value using some trial and error so that the final position and the final velocity were similar to what Tracker found it to be. So these were the results based on the computational model from GlowScript. As you can tell, the graph is very similar. The position versus time graph is very similar to the one Tracker outputted, and the final position is really similar as well. Unfortunately, the velocity versus time graph is slightly off. The velocity final does not hit 0, which is inaccurate considering the video's final velocity was 0. So I decided to find the coefficient of friction. I used that the friction force from my GlowScript was 0.0017 newtons, and my delta x was determined from Tracker, so I used this to calculate my coefficient, which came out to be about 0.0314. And as you can see here, I have an Excel graph of the observed and predicted positions versus time, and they're quite similar. There are some discrepancies between the initial and final positions for the computational model, but they are pretty similar and they both account for a frictional force. Finally, there were some error factors. There could have been some inaccuracy in finding the initial velocity, being that I used the first couple of points, which isn't entirely accurate. Furthermore, the initial force of the hand could have contributed somehow to the way the can moved. And towards the end, when it came to a rest, the can wobbled a little bit, which definitely could have contributed to this trajectory. So that's all on my Lab 5 for friction. Thank you.